Welcome, fellow space enthusiasts, to this explainer. I am absolutely thrilled you're joining me today because we are going to be looking at the single most important celestial body in our sky. We're going to explore the awe-inspiring, chaotic, and honestly quite beautiful biography of our star, the Sun. It's the engine of our entire solar system, and today we're going to uncover its deepest secrets. So let's dive right into this.
I want to hook you right away with a question that seems so incredibly simple, yet completely defies our everyday experience. Think about it. If I asked you to draw the sun right now, you'd probably reach straight for a yellow or an orange crayon, right? But what if I told you that the yellow color we see every single day is actually a massive atmospheric illusion?
Yep, it's true. In the pure, unfiltered vacuum of space, the sun is actually a blazing, perfect white. It emits all wavelengths of visible light totally evenly. It only appears yellow to us down here on the surface because Earth's atmosphere preferentially scatters the shorter blue wavelengths of light in all directions, which, by the way, is exactly why the sky is blue. What hits our eyes directly is just the remaining, slightly reddish-yellow hue. Mind-blowing, right?
Section 1. Birth of our star.
So, let's turn back the cosmic clock. Our sun's origin story begins roughly 4.6 billion years ago. Picture a massive, freezing, rotating cloud of gas and dust floating in space. Under the relentless pull of its own gravity, this cloud just collapsed in on itself. As the vast majority of that material was dragged into the center, the immense pressure and heat sparked something literally miraculous. About 4.57 billion years ago, nuclear fusion ignited. That flash birthed the G-type main sequence star, often just called a yellow dwarf, that anchors our solar system today. And right now, we are sitting right in the middle of its lifespan.
To truly appreciate what was born that day, you have to wrap your head around the scale. Over 1.3 million Earths could fit inside the sun. 1,300,000. The volume of this ball of hot plasma is almost incomprehensible when compared to our tiny, rocky home. Hey, if your mind is already blown by that sheer astronomical scale, please take a quick second to smash that like button right now.
Trying to mentally model how those branching statistics and global probabilities play out is essentially a massive, high-stakes math problem. And if you want to build the kind of analytical thinking to actually decode global data like this, you should absolutely check out Mathix. It teaches math in this incredibly fun, practical, and well-structured way. You get AI-powered support whenever you're stuck, an awesome active community section, and a really slick statistics dashboard to track your step-by-step progress. It totally takes the stress out of dealing with complex numbers. The link is right down in the description to get started.
Section 2. A photon's epic journey.
Before a particle of light, a photon, can travel to Earth, it has to be born. Deep in the core of the sun, the temperature is a blistering 27 million degrees Fahrenheit. At this extreme heat and crushing density, hydrogen atoms are violently slammed together to create helium in a process called nuclear fusion. Every single second, millions of tons of matter are converted into pure energy. It's a chaotic, violent birthplace, and this is exactly where our photon originates.
Now, the timeline of this photon's journey is just staggering. Once born in the core, the photon doesn't just shoot out into space. No, it enters the radiative zone, where the plasma is so dense that the photon constantly crashes into atoms, bouncing around in what physicists call a random walk. It can actually take between 10,000 and 17,000 years just to escape this single zone. Then, it rides boiling columns of plasma in the convective zone up to the surface. Finally, it bursts into the vacuum of space, completing its 93 million-mile sprint to Earth in just 8 minutes and 20 seconds. Think about that for a second. The sunlight warming your face today was actually born tens of thousands of years ago.
Section 3. Magnetic mysteries and auroras.
The sun isn't just a static light bulb. It throws some pretty violent tantrums. Because it's made of plasma, the equator actually rotates faster than the poles, which physically twists its magnetic field into massive knots. These knots inhibit heat from rising, creating sunspots, which are those darker, cooler patches you might have seen pictures of. Now, this magnetic tension builds up over an 11-year solar cycle until it literally snaps, causing violent solar flares and coronal mass ejections, or CMEs. When these massive waves of charged solar wind crash into Earth's protective magnetic field, they funnel down to the poles and interact with our atmosphere, painting the sky with the breathtaking colors we call the auroras. And while we know a lot about these solar dynamics, there are still some massive puzzles. Take one of astronomy's greatest unsolved mysteries, the coronal heating problem. The sun's visible surface, the photosphere, is a relatively cool 5,800 degrees Kelvin,
But if you move further away from the core, into the outer atmosphere called the corona, the temperature inexplicably skyrockets to over 2 million degrees. It completely defies basic logic. It's exactly like stepping away from a campfire and suddenly feeling thousands of times hotter. We still don't fully understand exactly how it happens.
Section 4. Earth's Shield and Shepherd.
For this part, I want you to imagine you're an astronaut, floating alone in the void of deep space, looking down at the mechanical clockwork of our solar system. The big question is, who's actually in charge out here? Well, consider the immense disparity in mass. The Sun contains a whopping 99.8% of all the mass in the entire solar system. Everything else, all the planets, including the massive gas giant Jupiter, all the moons, all the asteroids, every single grain of cosmic dust, that all makes up just a tiny 0.2%. The Sun is the absolute, undisputed gravitational shepherd of our cosmic neighborhood.
To really put that into perspective, let's compare the gravity. Here on Earth, we experience 1 g of gravity. It's a relatively gentle force that keeps our feet planted firmly on the ground. The Sun's equatorial surface gravity, on the other hand, is an immense 27.94 g. It is this exact, crushing gravitational tether that reaches all the way across 93 million miles of empty space to grab hold of the Earth, locking us safely into our orbit and preventing us from just drifting off into the freezing darkness of interstellar space.
And as our shepherd pulls us along, the Sun itself is orbiting the center of the Milky Way galaxy, taking about 230 million years just to complete a single lap. But compared to its galactic neighbors, our Sun is actually quite special. While it's officially classified as an average-sized yellow dwarf, it is surprisingly massive and luminous. In fact, our star is brighter than 85% of all the stars in the Milky Way, the vast majority of which are faint, dim red dwarfs. We are incredibly lucky to have the specific star we do.
Section 5. Myths to modern science. Let's return from the void of space back down to Earth. How did humanity actually figure all of this out? Well, I absolutely love this historical anecdote. Back in 1868, scientists were analyzing the spectrum of light coming from the Sun, and they noticed these strange absorption lines that didn't match any known element on Earth. They eventually realized they had discovered an entirely new element on a star millions of miles away. They named it helium, directly after Helios, the ancient Greek god of the sun. Get this, it wasn't until 25 years later that we finally isolated helium right here on Earth. From myth to modern science, our technological leaps have been just staggering. Ancient philosophers like Aristarchus and later Copernicus dared to propose that the sun, not the Earth, was the center of our system. Then, Galileo pointed an early telescope at the sun and discovered sunspots, proving the heavens weren't perfectly pristine. Fast forward to today, and we have incredible satellites like SOHO and the Solar Dynamics Observatory constantly monitoring solar weather. And even crazier, NASA's Parker Solar Probe is, right now, flying directly into the sun's blistering corona, effectively touching our star to unravel its final magnetic secrets.
Section 6. The Sun's Ultimate Fake. Like all great biographies, this story has to come to an end. Our Sun is currently middle-aged. In about 5 billion years, the hydrogen fuel in its core is going to run out. When that happens, the core will contract and heat up, causing the outer layers to massively expand. The Sun will swell into a monstrous red giant, expanding so incredibly far that it will engulf Mercury, Venus, and almost certainly boil away Earth's oceans, leaving it a dry, uninhabitable cinder. Then, around 7.8 billion years from now, it will violently shed its outer layers, creating a gorgeous, glowing cloud of gas known as a planetary nebula. After that, all that will be left is the core, a tiny, impossibly dense, glowing ember called a white dwarf, which will eventually cool over trillions of years into a cold, dark black dwarf. But hey, before we dwell too much on that distant, fiery apocalypse, let's remind ourselves why this specific star's life cycle matters so deeply to us right now. The sun's precise distance from us, its specific heat, and its steady light output are literally the sole reasons you and I exist. Its energy allows liquid water to flow, and its photons drive photosynthesis in plants, forming the absolute bedrock of the food chain that sparked the evolution of all terrestrial life. Without the sun, Earth would just be a frozen, lifeless rock in the dark. Which leaves us with a pretty massive thought to ponder as we wrap up. Knowing that the sun will eventually swell into a red giant and consume our planet billions of years from now, where do you think humanity's ultimate home will be? Will we hop to other solar systems, or find some crazy sci-fi way to survive the death of our star? I really want to hear your theories. Let me know your answers to this provocative question down in the comments below.
And if you enjoyed this explainer, please make sure to subscribe to the Zero Facts channel and hit that like button so we can keep bringing the universe directly to your screen. Thanks for learning with me today, and I'll catch you in the next one.